So this is the conversation around DevKit Heroes, and we're talking to top members from the community, the Element 14 community, about their top kind of development kits. So we've got on the Hangout, we've got myself, I'm Jen Patterson, the European PR Manager for Element 14. We've also got Cliff Ortmeyer, who's the Global Solutions Development Manager. And we've got Steve Donaldson, John Alexander, Shabazz Yousaf, and Peter Oakes joined us halfway through as well, so we've now got him on this part of the call, and Michael Kellett as well, who are all top members from the community. So I'll hand back over to Cliff now, and we'll start talking about the next section of this Hangout.
Great. Thanks, Jen. So we've got two things, and I think what I'd like to do is start off around the discussion around SBCs. You know, in our last discussion, we talked a little bit about what are some of the reasons that you like the platforms that are coming out these days. And one of the platforms that's taking on a whole new breadth is single board computers. Raspberry Pi, BeagleBone, Riot Board. You see a lot more processor-based systems that are coming out. And one of the things that we're wondering is, do you use those systems, just because of one of the things that was mentioned previously, do you use those systems as, I guess, baseboards or to set up a prototype build because you've already gotten something up and running? It might not be something that you're going to take into production, or maybe you will take that product into production. Do you use those boards to develop a base purely because you have a lot of experience with it and you say, hey, you know what, I can get something going? So if that's the case, you know, what do you like about them, and what are your favorite ones, and for what reasons? So
I guess.
Go ahead. Thanks, Shabazz. Go ahead.
I'd say both, Cliff. So definitely, I'm very well aware that a lot of the products that we work on, Element 14 Farnell have got development boards for them, and they do get used initially for some of the prototyping. And these are SPC, very popular ones. Some that I've used regularly. I can't really talk about those products, but also we use the actual boards themselves without having to create your own circuit boards. If we're doing demonstrations for customers, maybe I can show you some. So we do things like, we'll have an exhibition once a year which thousands of people visit. Also other ones where we're trying to do things with smart cities. So if we're trying to convey an idea to someone, then we'll actually just use the development boards to quickly come up with a quick proof of concept demo. And of course the real implementation might not use that, but still it's great for actually quickly showing somebody what's going on. So if I can just
While you're looking at that, or while you're looking, is the fact that most of, or a lot of them now are open source, is that a strong point for you?
It's a strong point for me because it makes it easy it makes it easy to get assistance if, say, for example, someone's probably already done something similar to what you want to do, at least the process, and that way you don't have to focus so much on that process trying to develop it yourself. You can actually go off of something somebody else has done. You can expand on that or use what you need of it, and that makes it, because like I said, the more minds working on a particular project, the better the project will be.
Okay.
I mean, that's also very true, but you got the idea, but the projects themselves tend to be, if you thought about them, right, they're quite complicated, generally speaking, if you thought about how you would implement them with technology which was 10, 15, 20 years ago old, right? But now we've got these boards, and they do majority of what you want, and they're quite well supported. And then you can take on, as I say, these bits of modules and whatever else which perform the specific functions, right? And you can expect them to talk to these boards. It's not like it's going to be unexpected, or there's going to be a lot of work involved in getting the electronics working, right, at a basic level. And you should be able to talk to these things and get a result from them, right? And because you can see, you get open source drivers for a lot of these peripherals as well, You find out that the software end is also a lot easier. You get the support. You can pull in support for the various drivers, make your own distribution if required, and pretty much for the actual dev kits situation, it's set bigger. But you've got these quite complicated boards which provide lots of functionality, and you save yourself a lot of time in just adding a few extra pieces, right? And you can get something like what you want very rapidly. And as Shabazz said, you might not actually use that in the end, right? But it gives you it gives you a proof of concept. And say if you're going to a customer and they say, well, can we do this? And you say, yes, you can, and here's something showing you that you can. And that you might not have budget at this point. So the time and effort, and it's always, I think it's your time. It doesn't matter if that board you're using is a £100 board or a £10 board or a £1,000 board. What really is the cost is your time. And I just want it to work. I want to stick things together, make it work, show them that's where you're going to go, and it looks something like what they want to do. And at that point, they can either agree to do something about it or not. But of course, up to that point, it's wishful thinking. As soon as you can demonstrate something, make it physical, then you tend to get the buy-in from the customer.
What percentage of the time would you say, I mean, just roughly, do you actually either take the board or pieces of the board and the layout and just put it into your own design because it's up and running, whereas it may be a little more costly, but it saves you time? Or do you, more often than not, just go back to your normal processor and what you already have now that you've already gotten a proof of concept done? How often do you actually use that piece of that development board or that system in your actual final design?
Well, myself?
Yeah.
I probably quite often use the whole lot and effectively consume it as a whole. And then the actual peripherals, I might do a separate board for that. So it depends on if it's just one-off, it might actually have a separate board for everything. But,
right.
If you're going to, it just depends on the volume. I think, to be honest, most of the time most people are not producing enough of any one thing to warrant lots of work in saving money. Because obviously it's work in for savings out, and it's all very well if you're producing, as you say, I think it was Michael producing, dozens to thousands of. Then if you're producing the thousands off, you're going to spend a bit of time to save the dollar.
Yeah.
But,
how about you, Michael? Sorry, go ahead.
Otherwise not, I think.
How about everybody else? What are your thoughts? Shabazz, what do you have there?
So you can see here, this is from one of our exhibitions where this is a smart city demo. So this used Arduino, and I believe it had a Raspberry Pi in there as well, controlling some of the gear. And it's just, with the Lego, it just makes it a bit more tangible for people. They can quickly get a bit of fun watching it as well in action. And I mean, the serious stuff there is that there is communication going on in the background. So from the sensors, there's information going out to routers or routers, and that information is then being sent up to cloud platforms. So if we're working with a vendor, for example, who might be developing some middleware or some other part of the solution, then they too can demonstrate showing screenshots live from maybe a web portal showing what's going on in the city as an example. And we had another example here, which is using a BeagleBone Black. So this is a quadcopter which one of our engineers developed. So he just used an off-the-shelf BeagleBone Black. It's got multiple cameras connected to that. And
I don't think it's changed over yet, the slide.
Not changed at all, yeah?
No.
No, not yet.
Okay, let me stop sharing and reshare that one, I think.
I see you looking worried.
Okay.
There we go.
Okay.
That's it. Yep.
Great. So with this, I mean, as you know, if there's wireless connectivity, then the chance of dropping packets, if it's like ISM band, for example, you may well be losing 30–40% of packets. So to be able to actually be able to show information being moved around from a mobile platform like this is a great test bed, and it's some fun as well. So if you've got some industrial sensors, you can actually connect them up to it and use this for showcasing technology, basically.
So you've done a lot with so you use the boards a lot, obviously, for showcasing technologies and prototypes and possibly to show marketing. What about in terms of transferring? How about anybody else taking these SBCs and using parts of them in the end product, or do you really just use them for quick prototyping?
Well, I use a lot of times starting with a launch pad or something like that, and just use it to get the development work done, and then it's pretty much taking the base chip, whether it be an MSP 430 or a 80 mega 328 or something, and then just moving it into a small production board. Because I mean, it's, I think, like John was saying, if you're only making 5 or 10 of them, it's not really worth going all out to try and optimize your bill of materials or anything like that. If you've got your base thing working on a prototype board like a Launchpad or an Arduino, then it's a very trivial thing to get a board made, a simple one, and move the same microprocessor just straight across to it using the same peripherals. And I think 20 or so units that you're making, and it's only if you go beyond that the difference between your time that you have to put in it and the cost difference it's going to make is worth doing anything.
Right.
So I see what they're saying, and I totally agree with the approach. And
I think that's such an issue with, say, the Arduinos of the world, because the devices are so simple anyway that it's quite easy to reintegrate, especially if you've got something that's like a vibration sensitive, or you want to keep in one piece. Then yeah, it's easy enough to redesign it. But if you start saying, oh, I want something which basically, let's say, a Raspberry Pi or a BeagleBone Black, then not only is the actual, quite often the actual design isn't that complicated because it's just bigger, but the constraints of making it right are obviously a lot more. And whether you can get all the parts at an economic price as well for very low production is a different matter. So you may well just say, well, I'll just have the whole device. I'm not going to worry about it.
Yeah, that's very true for things like, when you're dealing with Arduinos and Launchpads, the cost of doing a board is very, very low. But the minute you do start going into something like like a Raspberry Pi or an Atmel SMD or the Riot board, then to start developing one of those with the large BGAs and everything else, it gets a lot more complicated and a lot more expensive for that initial outlay.
So in those cases, you're more likely to stick with the actual processor that you're developing around, just because of unless you're going into the tens of thousands or millions, you're much more likely to stick with the processor that's on that board because you've already developed everything, got everything mapped out, correct?
Well, I'm even talking about sticking with the board even, and just putting a daughter board on it or an extension board, because of the fact that even trying to lay out a multi-layer board, I think pretty much anybody these days with a little bit of experience can lay out a 2-sided or a 4-sided board fairly easily. But once you start getting into BGAs and even just trying to get those reflowed onto the boards and things, you're taking it to that next level of complexity, and that's probably out of the reach of most people.
Right.
I think, from my point of view, the problem with most of these single-board computers is they're not built or designed for industrial use. So things like the BeagleBone, it's better than the Raspberry Pi, but most of them, there's no guarantee that they'll be making them next week, let alone 5 years from now. The software is, well, I would say it was suicidally dangerous for any company to use it on a significant scale, because none of the open source legal issues are resolved. So the chances are that if you use that, say, Raspberry Pi or the kind of software most people run on their BeagleBones or whatever, if you use it in a serious commercial application, you'll probably end up being screwed sooner or later, because you'll be breaking the rules somewhere. The difficulty, of course, is knowing where, because you'll be innocent and you won't know what you're doing wrong. So any of my clients would be absolutely horrified at the idea. They're happy to use one for a prototype or a one-off bit of test gear. But then, of course, the cost advantage of the single board computer over just using a PC isn't very great. I think John said earlier, you know, for one-off, what really matters is the time. So why not just buy a PC? There's a lot to be said for that approach. Comes with a power supply and a box, and if it breaks, you just plug another one in. I have had one or two people consider taking something like a Beagle Bone and then buying the chips and using, you know, building it from scratch, and that's quite a big undertaking unless you've got a significant number of them, and then there are still all the software issues to resolve, and those are, for most of my clients where that's been considered, that's really been the thing that's totally put them off, is that even once you've got your little TI processor from the Beagle Bone running on your own board, then you've got to have a Linux that you're going to have to maintain it yourself, and that's a big undertaking, and it wipes out a lot of the cost advantage over going to a more credible industrial source for a sort of complete working package.
Okay.
I mean, this is a time of support, though, isn't it? You've got a product, and I was saying, yeah, doing some bits and pieces with the Odroids, right? And they're basically a telephone-style product. So I mean, a telephone-style board and telephone-style chips, and they're great devices, right? But if you wanted a 5-year run time of them, or 20 years, or some of these really, you know, deep industrial devices, you know, you want incredibly long sort of, like, it's just not going to happen. You'd buy them and store them if you wanted to, right? That would be the only way to keep any sort of reasonable guarantee of supply, and you'd have to be very familiar. In this case, it's always Linux, but yeah, got to be very familiar with Linux and building building a platform that works. You could end up a year, 2 years down the line where you're basically you're in the lurch, and it's not necessarily just these type of products, even just normal software-based products, but particularly embedded, where you've got physical size, you've got a price. You've got, will it stand up to the vibration, and then general use? Can we even power it without a car battery, right? And can we put a display on it? Does the touch display still work, right? And all these little irksome things, and they all require drivers more often than not. And if you start to, as the thing evolves, right, you very rapidly evolve away from this comfortable solution which you've got going, and you've got to re-evolve not only some of the peripheral parts, but sometimes quite a lot of the core, right, and start again. So you could find out that by using a lot of the open source parts, that you are actually taking on board a lot of potential rework. It's not so bad if you've got a grounding in this area, and also willing to, I've either got a product which is only going to be for a very short run and doesn't matter, or full well it's going to be re-evolved into several revs, and at that point, actually reworking it's a part of the game anyway, and otherwise, I think it can be quite scary, actually, because a lot of people, even with these various foundations, and they say, "Oh yeah, we support you, right, and we really appreciate your business, as it were." They only support you for as long as their current device is out. They're not going to see you maybe in 6 months' time, right? They say, "Well, you're going to need to buy the next device on." And that might not be an issue for you, and you find out that you can't use different versions of kernels, and you can't, and then you got to support quite a lot of that chain yourself. If you could do it, or you're used to doing it, it's great. But if you're not used to it, it's a total pain, and it's a lot of knowledge over and above the electronics knowledge, right, or even the sort of basic software knowledge, in order to maintain, tool chains in itself, or or Linux devices in themselves. It's a complete whole different technology. As a separate stream of work.
Yeah, I mean, a couple of the popular boards that we use have made it into products which will be launched soon. But then there's a whole team of engineers behind that, exactly working on the operating system, all the board support packages and everything, all the software. But also what we found is the manufacturer actually helps quite a lot as well. So they don't actually mind even helping with some of the design and also the code as well. So with some of the larger manufacturers, we found they've been very helpful, just providing us with all that support.
Okay. Steve, anything else from your side before we wrap this one up?
Well, it's from what I've seen, a lot of times we'll use a development board, but it depends on who is supporting the development board. For many years, for example, Agilent, they were using embedded Windows, and I think they still do in some of their test equipment. I mean, it's kind of funny. A customer walks in, you're playing solitaire on a network analyzer, But it's to have, as long as you have a fairly robust system you can play with. In fact, a lot of the modules now that are coming out, the single board computers, they're pretty powerful in their own right. They have a lot more capability than the old PCs of 10 years ago. I mean, you wouldn't dream of doing half the stuff they do now, or as back then. You'd need a room full of computers and stuff like that. So, to be able to, as long as you have an operating system or an IDE, as it were, to maintain it properly, that they're not going to change in five weeks. So it's not backward compatible anymore. I think you'll be okay. That's why, in some cases, we might have to develop our own things using that chip, or we might have to, like I said, a lot of times I'll use the dev board itself just because it doesn't take up as much time, like John said, or it actually works. As long as it works and it's robust enough to handle being beat around a little bit, I'm okay with it.
Okay.
I just like to say, I mean, like for example, the BeagleBone Black, we end up using that a lot because the amount of throughput you can get on that thing is incredible. I mean, I've used it to maybe 150 megabits per second of data, pushing that in because it's got extra processors built in, so we don't have to use FPGAs or anything. But theoretically, it's possible to shove about a gigabit per second into the BeagleBone Black in parallel. So parallel data into there, you can manage about a gigabit, which is just really great considering it's like $40 or something.
Yeah, that's awesome. I mean, it sounds like what we all believe and understand seems to be true, that these things really are helping the base development and prototyping. And if it works for you for the low volume, that's great. And high volume, we're still kind of back in the old school where we gotta it's great to get it up and running and show marketing, but now we gotta get the cost out of it. So at least I got a good path for that. All right. Well, I want to thank everybody for their time today on this topic. Jen, you want to take over from here?
Yes. Thank you very much, everyone. That was a really interesting discussion around single board computers. So I'd like to thank everyone for participating in that element of the discussion.